So there are basically two ways of doing things. My first attempt to work with it was to actually jump to the driver program and look at the main function, just to see, okay, what's going on, what's involved, what's happening. And I tried, doing my best to interpret the classes and references to classes. Of course, this is using pointers, but I call them references because if we wanted to rewrite this in Java, we'd be using Java object references, right? But and then this was helpful too because it gives us somewhat big picture of what's going on. So we already explored door, room, wall, bound wall, map site, maze, right? Maze factory, bomb maze factory, the game thing, right? Object array and object link we'll ignore for now because there's some sort of helper classes to organize collections. I don't even care about that. That's just really something specific. Rather, what I would like to look at is the sequence diagram, okay? So the sequence diagram for simple maze. Why is the sequence diagram for simple maze? Because we said that when we create a factory which will be manufacturing all of these walls and doors and rooms and so forth, we would like not to use bombed versions of walls. That's why we use false. When we say factory instance, we pass this false to that method, and we say that we want a simple one. So here's the sequence diagram. Once again, this is part of our website for this demo. And so this sequence diagram is just a way to explore all of these classes at runtime, basically. So here's main, right? So we enter into main, and the operating system loads this program into memory and calls main. The sequence diagram tells me that the first thing that happens is that the maze game object is constructed, right? So this is the name of the class, and when there is a sequence diagram shows me this call to maze game, and the name of the method call is the same as the name of the class. Obviously, this is the constructor. So if I check with my main, that's exactly what happens because we say maze game, new maze game, and that's exactly the call to the constructor. And new, of course, creates a new object, right? So this line of code right here becomes visible on the sequence diagram, right? So if I compare both of these, right, you can see that that's exactly what's happening. Main is invoked, and the new object is constructed right here, and the constructor of maze game is invoked, and that's what the sequence diagram shows. Then the control returns, so the object gets constructed. We keep reference to it right there, right? But we continue on to proceed to the next part, which is call factory instance. Factory instance is not a class, this is just a method call. I recall that we documented it as kind of utility thing. We said that factory instance returns a maze factory, and it actually instantiates it if it needs to call the constructor. It's part of this utility class that we use. So this is how it's visible on the sequence. And we say, just call this method, obviously call method name factory instance. And we see that because we pass false to this parameter, it creates the maze factory object and not the bombed maze factory, right? So we want to use the factory to construct other objects. It's really the factory object which will be responsible for constructing other types of object in the system. Okay, so the maze factory constructor here is visible. You should recognize this is the constructor of this class because it's the same name, so obviously it's the constructor. If we want to verify it in the code, right, we can always go here and say, okay, show us the actual definition of this. And so, yes, here it is. Here's the constructor of the maze factory. If you compare it with my with my sequence diagram over here, you will see that yes, indeed, factory instance right here constructs maze factory right here and remembers it as factory instance, right? So factory instance, in fact, is like a static reference which exists in global scope, and we basically control it through this method called factory instance. So then the story goes on, right? So the sequence diagram shows us what really is happening during the execution of this code. This is a perfect tool to analyze the dynamics of the actual execution of this main use cases, if you will, right? So the next thing happens is that once the factory instance, which is the maze factory object, is constructed, control returns back to main, and the next thing that happens, we say create maze. All right, interesting. So let's take a look at this. Right, just switching back to my driver thing, which is here. So yes, we say that if the factory construction was successful, then we say game, which is the maze, create maze. Okay, so maze game is the actual object or rather class name that we use to do other things, and it has this create maze method. So from main we say maze game, please create the maze. All right, so that begins to start working, and it's visible right here. In fact, main does indeed call create maze, and this create maze is the method that belongs to class name maze game, right? So because that's what a game is, and we create it as maze game. So moving on, so what's going on here? Now, without much detail, just very quick a quick view of this. Remember that create maze takes a reference to the factory instance, actually reference to the maze factory object, and to construct everything, create. In fact, we should look at create maze, because it's what create maze does, right? Create maze actually has the map, the structure. It's the method which keeps track of the topology of the maze, right? It knows that what it wants to do is it knows that it wants to create the maze first, then it wants to create room 1. Again, I will simplify some of this code for you. It creates 2 rooms, room 1 and room 2. It has hard-coded room IDs. Remember, make room takes a parameter, and constructor of the room wants to take the room ID. So here they are, hard-coded here as 1 and 2. Right? Then it wants to create the door. Again, I'll simplify this notation. It creates the door, and it now can create the door successfully, because now it says make door, and passes room 1 and room 2 as the 2 object references that the door wants to have. Recall that when we constructed the door wants to have access to the 2 rooms. Its constructor, of course, takes room 1 and room 2. It requires that, right? But a little observation that this create maze never does create these objects like rooms and doors and walls and so forth directly. Instead, it takes reference to the factory and says, factory, you do this for me. You know how to create individual objects. I have the entire topology of the whole thing, but you know how to manufacture individual objects, right? And so therefore, if we go back to the sequence diagram, you can see that maze game and its create maze, this method that we're just looking at, it asks the factory to do all the work. Make maze, make room, make another room, right? Then make door, and then apparently what happens next, that it, if we look at this part of the create maze, right? So maze factory simply invokes constructors for the maze, the room, another room. And interesting observation is that when, say, room is constructed, remember that in our case, door, room, and wall, they all derive from map site. On the sequence diagram, what it shows is that before room constructed, its superclass constructor is invoked, the map site, right? So the map site is invoked, and it's actually the superclass constructor of the room, right? Because room derives from map site. And therefore, on the sequence diagram, it's hard to show everything correctly because the constructors are invoked independently. In fact, map site constructor, you can see, is invoked completely independently before the room constructor is invoked. And that's just the nature of superclass and subclass type of construction, right? But so although these two constructors are visible as two separate method calls for the map site and for the room, however, make no mistake, it's the process of make room saying new room, and that's where the room is constructed, right? So obviously make room returns a reference to this room that it constructs, and somehow create maze keeps a reference of everything. It just basically says, okay, I will remember everything that you're creating. So similarly, make another room. Similarly, make door, right? Make door basically creates the door, and again the door derives from the map site, so therefore before the door constructor executes, the map site constructor executes, because it's a superclass for all of these silly objects that we use as map sites. Then this business with add room, let's take another room, look at the code. So basically we constructed the maze object, right? And then apparently the maze object has the method name add room, so that the maze can keep track of rooms. Apparently the maze has a collection of rooms, and it stores internally room 1 and room 2. So we need to access these rooms. We should be able to, and so we call this add room. I don't even care. I suppose it's a pretty trivial, pretty trivial method, which essentially updates collection inside the maze, and apparently the maze has collection of rooms, right? And then, so once we did that part of configuration, so obviously now we kind of hold the entire topology inside this maze object, right? Because the maze object now has a list of rooms, and we finalize everything by actually saying room 1, you need 4 sides, right? North, east, south, and west, in this specific order. This does, and it basically says, all right, this room 1 will have 3 walls. We simply say factory, let's make 3 walls right there, right? And also let's use the door that we already constructed earlier that connects room 1 and room 2, right? So obviously, there's basically the east and west, right? For room 1, the east side has the door, and for room 2, the west side also has the door, right? So this finalizes the work, and we basically construct the maze using the factory, right? So create maze does everything in terms of the topology, but individual objects are manufactured by the factory, which was created by us pretty early, right? So we said before we even begin working with the maze, right? The very first thing that we did in our main method was let's construct the factory. In fact, we constructed just a simple factory, right? So this is what's going on in the this is what's going on in this create maze. It's a pretty long method, right? So when it's done, right? So what happens next? We say maze print. Apparently, the payload of this entire arrangement of objects and everything is done through the print method. And guess what? The main method simply says maze print, and print apparently is delegated through the entire collection. And you can see from this sequence diagram that what we do pretty much is that the maze, when we call maze print, maze then apparently goes through the collection of all rooms that it keeps track of and basically says print room, and then print room does whatever it's supposed to do, but then it prints the walls, prints the doors, and so forth and so forth, right? So this is where we get our output of this structure that everything is printed, right? So this kind of demonstrates construction of a simple wall. And so we don't have a lecture on Thursday because it's a Monday schedule, right? However, we will spend just a few more minutes to finalize this and look at the BOM version of the factory so that we can construct different type of object. And you can already sense that because we're now capable of using this type of factory or that type of factory, it will be very successfully constructing this type of wall whenever needed, and that type of wall likewise. So that is just something that we need to finalize. But again, our highlight is essentially using class diagram to represent classes and envisioning some of these relationship between the between different parts of our application. So to be continued. So obviously this is kind of has a lot of different moving parts, so we were not able to finish everything today, but it is to be continued. So I'll see you guys later. Thank you.